Hello, thank you for watching this video. So in this video, we're doing question 10 of November 2024 question paper mathematics paper 1. And the topic is Euclidean geometry or proportionality if you want to. So they're saying, in the diagram, triangle RST is drawn. Line AB intersects RS and RT at A and B respectively, such that AB is parallel to ST. So what they're saying you're given triangle RST, right? And you have your AB, which is this line over here, that intersects your RS and your RT at A and B respectively, right? They went on to say that your AB is parallel to the third side of your triangle. Your AB is parallel to the third side of your triangle, which is your AB is parallel to ST. Fine. They are saying now, prove the theorem which states that a line parallel to one side of a triangle divides the other two sides proportionally. So, they want you to prove a theorem which states that a line joining two sides of a triangle, right, such that it is parallel to the third side, will divide the two sides of your triangle proportionally. Which means in this case, what they wanted to prove, they want to prove that your RA over your AS should be the same as your RB divided by the BT. That's what they wanted to show here. So they wanted to show that the ratio of RA to AS is the same as that of RB to BT. So if you're saying your ratio of RA to AS is equal to that of RB to BT, it does not necessarily mean your RA is equal to RB and your AS is equal to BT. I explained this at question 3. So the numerators are not equal in general, which doesn't mean this length over here is the same as that length, and that length down there is the same as that. Which is the ratios of those lengths, your RA to AS and that RB to BT, are equal. So for example, your 2 over 4 is equal to 1 over 2. But it doesn't mean your 1 is equal to 2 and your 2 is equal to 4. That's what I'm trying to say. For example, you can talk about two ratios. Look at 3 over 6 is equal to 2 over 4, which they are all equal to 2. But look at all these three things. They are not the same. Doesn't mean 3 is equal to 2. Doesn't mean 3 is equal to 1. They're just of the same ratio, which is these two things, they simplify to that simplest ratio, which is 1 over 2. So it does not mean they're the same. So what I'm trying to say is that in general, it does not mean your RA is equal to RB and your AS is equal to BT. So, but what they wanted to prove here, they wanted to prove that your RA, which is this length here over your AS, is the same as that of RB over your BT. That's what they wanted to show. And also what you need to do, actually what you need to know, is that this is not the only ratio that you can deduce out of this. As long as you take the ratios of the similar parts, or same parts, then your ratios will be equal. For example, if I were to say you are A, so you are A over the entire RS, it should be the same as your RB on the other side over your entire length side as well, which is RT. So your RA is just this top length here. Look at your RB is the top length there. Your RS is the entire side and your RT is the entire side. So it does not matter which parts you take as long as you are consistent. So even if you can say your AS over the entire thing should be the same as your BT over the entire thing. As long as you take the ratios of the same parts, then those ratios will be equal. That's what this thing means. It is not necessarily stuck to this ratio, just this ratio over this one and this part over that part. It does not necessarily end there. As long as you take the ratio of the same parts, then it should be equal. Those ratios should be equal. So I'll clean this. So we want to prove this now. So how do we go about this? Let's say proof, right? Under our proof, we'll need to construct a few things. We'll need to do a few constructions. So, what do we do? The first thing that we will do, I will say let's draw two altitudes, right, from A and B. So we're going to draw two altitudes, right, from A and B. What is an altitude? An altitude is what maybe by now you know as the perpendicular height of a triangle. So let's say you have a triangle here. I'm going to call it triangle A, B, C. So if you're talking about an altitude, you are talking about a perpendicular height, right? So a perpendicular height from A, actually an altitude from A is a perpendicular height or length from A to the opposite side. So A is facing this side, so it's this perpendicular height here. This is H1. So if you're talking about a perpendicular height from C, it's the perpendicular height from this one, so it will be the height that will go to the side. And the perpendicular height from B will be height over there. So what we're going to do, we want to draw altitude from A and B, right? Where? In triangle RAB. So in this triangle, we want to draw two altitudes, which means two perpendicular heights from A and B. That's what we're going to do. I'll use a red ink. So let's draw the first one. We'll draw the first one from A. So let's say from A, here is A over here. If we want to draw in RAB, we're going to draw perpendicular heights in this triangle over here. So this looks similar to this, right? So if you want a perpendicular height or altitude from A, it will start from here to the opposite side. The opposite side is this one. So it will be a perpendicular height like this one, perpendicular over here. And let's call it maybe height 1, right? And we need another altitude from B. Here is B. The perpendicular height will be towards the opposite side. It's over this side. So here is your altitude here. So your altitude is what you normally call your perpendicular height. Fine. We do have it. We have those. Fine. So after doing this, look what you have here. Look what you have. You have your RA. What is your RA? Your RA is this side over here. You have your AS is this side over here. You have your RB is this side over here. And you have your BT is this side over here. So, what do we do? What we need to do first, we need to calculate the area of this triangle RAB. So we can calculate this area of triangle B in three ways, right? You can say half base here times perpendicular height, which is this one here. Or we can say this base is this one here, this base is here, times the perpendicular height of that one. Or maybe you can say maybe this is your base as well, times the perpendicular height. But we didn't need the altitude for that. The reason we didn't calculate the altitude for that is because if we're using AB, we don't see AB anywhere on this. Here, we don't have any AB. It would be good to use your RB and your RA because you can see your RA, you can see the RB as well. So if you use your RA and your RB, you'll be using this side and this side, right? You'll be using your RA and your RB, which you already have here. You can't use your AB because you don't have anything about AB. What are you going to do with AB? So that's why you didn't even bother drawing an altitude about AB. You wanted to use the side that are related to what you can see here. So what we can do, we can now calculate the area of triangle RAB. So let's go and find it. So the area of triangle RAB, we're going to say is half base times the perpendicular height, which is your altitude, right? So which is called what? You can say it's half your base. What is your base? We can say our base is RA here. RA times our perpendicular height. Our perpendicular height for RA is H2, if you can see. It's going to be half base RA times perpendicular height, which is H2. right? So this is the area, this is your area of triangle RAB, right? No problem. Or you can calculate the area of triangle, you can also calculate it from this side as well. So these areas are equal. Actually, let me not even underline it because we're not done. So your area of triangle RAB is equal to half base, which is your base is RB, times the perpendicular height. What is the perpendicular height? Perpendicular height is H1, because if your RB is your base, the perpendicular height is R1, which is H1, which is the altitude. So these two areas, this is the same area because it's the same triangle. So it doesn't matter which base you use. If you're calculating the area of the triangle and you have the perpendicular height from each of the base that you select, the area will come out the same. So this area and this area are equal because it's the area of the same triangle. Even if you were to say AB times the perpendicular height, which is the altitude from here, it was going to come out the same. No problem. So we're done with this triangle over here. So which means we said something about RA, we said something about RB. Now we must try to say something about AS and BT. That's what we're going to try to do. Where is AS? AS is this side over here. So we need to try to say something about AS, which is this side over here. So to do this, we're also going to use an area, which means we need to calculate an area, right? Another area. Because we used areas to talk about RA and RB. So we need another area that will talk about AS, right? And so is BT. You need another area talking about BT. So how are you going to do this? So what you're going to do is, you're going to do what? We are going to join RB, SB, like this, and join your AT. Let's write it on our construction. Let's say join what? AT and BS. We joined those two. Once you join these, you can see that now, if you look at your AS here, AS is on a triangle ABS. AS is on a triangle ABS over here. So you can find the area of this triangle, right? You can find the area of this triangle because you can say this is your base AS and your perpendicular height, where is it? There is a perpendicular height of your triangle. Because, you know, if you're calculating areas of triangles, your triangle can be like this, which is the very common one. Here's your perpendicular height over here, right? Or you can have an obtuse triangle like this one over here, right? You can say this is an obtuse angle. So where is the perpendicular height? The perpendicular height is this height over here. This is, you have something like this there. You have an obtuse triangle. So if you look at it, this is an obtuse angle over here. There's an obtuse angle over there. So your base is your AS and your perpendicular height is H2 over there. So you can be able to find the area of triangle ABS, right? And you can also be able to find the triangle of what? You can also be able to find an area of a triangle with a base BT, because look, ABT is also a triangle over there, right? Its base will be BT, and its perpendicular height, you can see it over there. It's H1, which is also an obtuse triangle like that one. So what we're going to do, we're going to calculate the area of triangle ABS, because we want to have another area that we will be able to relate to this. So let's find the area of triangle ABS. So we say in triangle ABS, right? The area of triangle ABS is ABS, going to be half base. What is your base of your ABS? Is AS over here. Going to AS times the perpendicular height. Where the base of AS is this one. Where's the perpendicular height? The perpendicular height is that one over there. Because you can see half base times the perpendicular height, which is H2. Right? No problem. We can also be able to find the area of triangle ABT. So, you can say now the area of triangle ABT is equal to half base, which is your BT, times the perpendicular height. If your BT is your base, what is the perpendicular height? Perpendicular height is there, it's H1 over there. It's H1. So, we discovered that these two areas, this one and this area, are equal because this is the same triangle. So if you're calculating the area of the same triangle, it should come out the same, right? No problem. Now, we know that these two are the same because it's the same triangle, but just use different sides, right? Now, let's come to the other two triangles, these two triangles, and try to relate their areas. Triangle ABS, look at it. Triangle ABS. ABS, here is it. And look at triangle ABT. ABT. If you look at these two triangles, ABS and ABT, you can see that they have the same base AB over here. Right? They have the same base AB, ABS. You can say it's this. You can say they share the same base if you look at them. ABS and ABT, because you can see they have the same base AB, both of them. Now, what is their perpendicular height? Like I said, these are obtuse triangles. If you can extend this to some degree, the way I did here, you will find that the perpendicular height of ABS is somewhere here. And ABT, its perpendicular height is somewhere there. So look at this height, let's say H3 and H4 over here. So these are the perpendicular heights for both of these triangles. For ABS, here is the perpendicular height. For ABT, this triangle ABT, here is its perpendicular height. Because you can say, if you want this triangle, you can say it's half base times perpendicular height. You'll find the area of this triangle over here. Because it's going to be half base times perpendicular height. And if you want to find the area of ABS, it's going to be half base times its perpendicular height over here. Because you can see your triangles like this here. So the base is AB times perpendicular height. And the area of this triangle is half base here times its perpendicular height over there. So it's another way of calculating the area of those two triangles, but using different sides as opposed to using this one as the base or that side as the base. Now, here's what you need to understand. These two lines AB and R and ST, they are parallel. So if they are parallel, the distance between the lines is always the same. Which is the distance between AB and ST is the same anywhere. Which is the perpendicular distance between AB and ST would be the same at every corner. Not corner, but at every point. Because they are parallel. They never meet, which is they are equally distant apart the whole time. So, which means if you're saying that these are equally distant at every point, the distance between them is the same at every corner, your H4 over here and your H2, they should be the same, which means there should be these two triangles, ABS and ABT. They have the same base and they have the same perpendicular, and they have equal perpendicular heights. In that case, if your triangles have the same base and have equal perpendicular heights, their triangles, their areas will be the same, because the area of the triangle is half the base, which is the same in both of them, times the perpendicular height will be the same in both of them. So in this case, the area of triangle ABS and ABT, they should be the same, because these triangles, they have the same base, your AB, and the same perpendicular height, because it's the distance between two parallel lines. So, what I'm going to say here, I'm going to say, okay, therefore, the area of triangle ABS is equal to the area of triangle ABT. Why? Because this triangle has the same base. What is your base here? Your same base is AB. Right? And also same perpendicular height between them. Or same altitude. Same altitude. Altitude. Yes, same altitude, right? Which is, that is the distance. That is the perpendicular, that is distance. between your parallel lines. Right? That is the distance between your parallel lines, because you know that your AB is parallel to ST. So this area and this area are equal because they have, these two triangles have the same base and they have equal perpendicular heights between two parallel lines. So in this case, once you are here, you look at your RA and look at AS. Look at the areas that involve RA and look at the areas that involve RA and AS. The areas that involve RA and AS, which one is this one over here? This one over here, and AS. Which area involve AS? The area that involve AS is this one over here. Right? Look at the areas that involve RB. Look at the areas that involve RB and BT. RB, you can see here's your RB over here. Here's the area that you have your RB. Where's the one that involves BT? The one that involves BT is this one, is over here. So what you do, you just take the ratio of those two triangles. And those ratios, you take the ratios of those areas. Because the ratios of those areas, you take the ratios, this area over this area, because this area here of the small triangle of the top triangle over the area of the bottom triangle. Area of the top triangle over the area of the bottom triangle. And you should be fine from there. So, what I'm going to say from here, I'm going to say, I've indicated that my RA and AS, here's my RA on this red underlined thing, and my AS on this red underlined thing. So this area of this small triangle RAB is the same as the area of triangle. Actually, no. Let me write it down. So the area of triangle RAB over the area of triangle what? Which is it's a red one. I'm coming to the red one. Of ABS is equal to what? It is equal to the area of triangle RAB again, but for the green one, over the area of another green, which is what? Triangle ABT. Look, this and this are equal, which is the top area and the top area, they are equal because it's the same triangle. Because if you calculate the area of a triangle in two different sides, it will come out the same. Because it will come out the same. So this area and this area are the same because they are both area of this top triangle, but you use this side as a base, and on the other one you use the other side as a base. But look now, the area of this and this, will just explain that they are the same, because I explained that these two triangles, this ABS and ABT, which is your ABS and your ABT, they have the same base and they have the same perpendicular height, which is the same altitude between the parallel lines. So these two, if they have the same base and they have the same altitude or perpendicular height, these areas should also be the same. Which is the top is equal to the top, the bottom is equal to the bottom. So their ratios should be equal. Right? Their ratios should be what? Their ratios should be equal. Because we just explained that they are equal because this and this are the same because the same triangle. These are equal because they have the same base AB and they have the same perpendicular height between the parallel lines. So what do you do from here? Just substitute your area for triangle RAB, the red one. So the area of triangle RAB, the red one, is half your base, which is RA, times the perpendicular height, which is H2, all over what? All over the triangle, area of triangle RABS, which is half your AS, times your H2 is equal to what? It's equal to half of your triangle RAB, but the green one, which is half RB, times your H1, all over half what? Half BT times H1. If you simplify, this and that go away, this and this go away, this and this go away, this and this go away. Therefore, what you are left with is what? Is your RA over your AS, which is the same as RB all over BT. So this is what they wanted to prove, which I believe is this one over here. Yeah, it looks like it. And this is how I would have done this. And I hope it does make sense to you as it does to me. I think I'm done with it. I tried to explain it as much as possible. I'm going to go to the next question, which is 10.2. I'm going to clean the board. This was 10.1. So let's clean the board and we move to 10.2. Okay, so now we're done with 10.1. So we're going to do 10.2. At 10.2, they're saying, in the diagram, O is the center of the circle. Triangle PWS is drawn with P, W, and S on the circle. OR is perpendicular to PS, and PRS is produced to T. ST and OT intersect at V. The ratio of OV to OT is 1:4. So, they're saying now, you have a circle with center O here, right? They're saying now, triangle PWS is drawn. So you have triangle PWS, as you can see here. No problem. It also looks like you have another triangle PWR as well. They went on to say that your OR is perpendicular to PS. PS is this line here. You have your OR perpendicular to PS. There is your 90 degrees there. Fine. They went on to say that PRS is extended to T. PRS is extended to T. So it is produced to T. Fine. They went on to say SW and OT intersected V. So you have your SWT, you have your SW and your OT. They're intersecting there at V. They're saying now the ratio of OV to OT is 1:4. So the ratio of OV is to OT is equal to 1:4. If you write it maybe in simple maths, I'll say your OV over your OT is equal to 1/4. Right? No problem. Does that mean OV is equal to 1? No, it's not 1. Does that mean OT is equal to 4? No. So what it means, your OV is equal to 1 times something. Let's say 1 times A. And your OT is 4 times the same A over there. So the ratios of these two sides, they simplify to this. It does not necessarily mean they are 1 and 4. Yes, they can be 1 and 4. But not in general. It's not true in general that it's 1 and 4. But your OV to OT, they simplify to 1/4. So keep in mind that this doesn't necessarily mean it's 1 and 4. It means it's 1 times something and 4 times something. So where is your OV? Your OV is from here to here. So I can say it's 1A, the OV. From here to here is 1A over here. From here to here is OV. Your OT, it starts from here to all over there and it's 4A. So if this is 1A, then this should be 3A over here. So all of it should be 4A. Because this is, it's like OV is equal to 1A, so it's 1A. And your OT, the entire length, is 4A, which means if this is 1A, this should be 3A over here. So that your 1A plus your 3A, they give you the entire T, which is 4A. That's how I look at proportions. Fine. Now let's move to 10.2.1. We're going to do 10.2.1. At 10.2.1, they're saying prove with reason that OR, the ratio of OR to WS is 1:2. So they want us to prove that the ratio of OR to WS is equal to 1:2. They want us to prove this ratio over here. So, what are these? The OR is to WS, WS is this one over here. They want us to prove that this side over this side is equal to half. No problem. So, what do we have here? So these two sides are in this bigger triangle PWS. If you look in triangle PWS, they are both in both of these letters inside the triangle. So what you have to some degree, you can say, okay, I have my PWS here, I have my POR here, right? This is some sort of a proportionality theorem, if you think about it. It's a special kind of a proportionality theorem. How is it special? So, what you need to know, or what you need to remember, is that, look, you have your PO, this length from here to here, is equal to your OW. Why? These are radial. Because these are radiuses, OPO and OW. So these two are radiuses. Fine. What else can you say? Look at this angle S here. This angle S here is formed by PW. And PW is radius and radius. So these two are equal. Right? We just said that these two are equal. So this PW is a diameter. So your angle S over there, this angle over here, is formed by a diameter, the PW. And you should remember from your grade 11 Euclidean geometry that a diameter subtends a 90-degree angle. So that angle S over there, it should be 90 degrees because your diameter subtends a right angle. So this angle S is formed by what? By PW, and PW is a diameter. And you know diameters, they subtend a right angle, which is a 90-degree angle. So what you can say, look, this angle S over here, let's say it's PSW. This angle S, which is the angle between PS and SW, which is angle between PS and SW, which is that angle over there, is equal to 90 degrees. Why? This is angle subtended by a diameter. And the reason for that is say angle in semicircle. That's what we say. This is an angle in semicircle. So, what you can say now, say, okay, we know this angle over here is a right angle. So look now, we have corresponding angles of OR, and look at the angle R and this angle S here, right? We have two lines intersecting the same line there. So we have two lines OR, this line OR and WS. They are intersecting a same line PT at the same angle. What does that mean? It means those two are parallel. If you were to watch my bad actions, it's the first thing that I teach, angles or on parallel lines. So the angle R and angle S, angle R and angle S, those are corresponding angles. Your corresponding angle R and angle S are equal. So if you have two corresponding angles between two, if you have two lines intersecting a transversal, which is a third line at the same angle, then the two lines are parallel, which means your OR is parallel to WS. Go to my playlist and watch my bet actions there. On my bet actions, I explain this clearly. So, in this case, this angle here and this angle here, they are what? They are equal, and they are both equal to 90 degrees. If they are both equal to 90 degrees, it means these two lines have the same orientation. They are parallel. So you can say that your PRO, right, is equal to 90 degrees. You are given this thing. So the angle R between PO and RO does 90 degrees, you are given. Therefore, your PSW is equal to your PRO, and that was equal to 90 degrees, right? Because you can see this is 90, this is 90, therefore these two are equal. So what you can conclude, you can say therefore now, our OR is parallel to WS. Why? Because the corresponding angles are equal. You have these two corresponding angles that are both equal to 90 degrees. So these two lines, your your WS and your OR, they are both parallel, which is they have the same orientation. Look now, what we have is some sort of your proportionality theorem, right? Some sort of your proportionality theorem. But it's a special kind of proportionality theorem. Because look, if you say, let's say we're trying to apply our proportionality theorem here. And we say, what is it? Let's say we say PO, which is I'm looking at this triangle. I'm trying to look in triangle POR and triangle PWS. Then I say in triangle POR and triangle PWS. I'm looking at these two triangles, POR and PWS. So let's say we say PO over OW, which is what similar to what we proved on the other side, is equal to PR there over your RS. We can say this is our proportionality theorem, this one, which is just proved in the first question. Why do we use this? Because OR is parallel to WS, which we should just prove over here. So we can apply the proportionality theorem. But look, at your PO and the OR, your PO and the OW, your PO and OW, these two are equal. We also said that your PO and OW are equal because these are radii. So what you have here, you have a triangle, right? PWS, right? And a line OR that starts from the midpoint of one side, because O is the midpoint of your PW. So you have triangle PWS and you have OR that joins a midpoint of one side of a triangle to that joins a midpoint of one triangle by OR to the other side, and that line is parallel to the third side. This is a midpoint theorem, because look, this and this are equal. Actually, it's not a midpoint theorem, it's the converse of the midpoint theorem. Because remember, if you were to watch my back actions, I did midpoint theorem as well. This is what the midpoint theorem says, and it's a special case for proportionality theorem. Look, so this is the midpoint theorem. What is the midpoint theorem? It says if you have triangle ABC and the line DE, right? And the line DE, such that this line DE joins the midpoints of both sides of your triangle, AB and AC, D and E respectively. What will happen is your DE will be parallel to your BC, and the length of DE will be half of BC. Right? So your midpoint theorem, it says that if in this triangle your AD is equal to your what? Your BD, your DB, and I'll say your AD is equal to DB, and your AE is equal to EC. Then what? Then what will happen is that your DE will be parallel to your BC, which is this side will be parallel to this one, and the length of your DE will be equal to half that of BC. That's what the midpoint theorem says. So which means if you have the side and the side and there's a line that joins the midpoints of these two sides, what that will happen is that this will be parallel to this and the length of this will be half of that. That is the midpoint theorem. The converse, what does the converse say, which is the other direction? So this is the midpoint theorem, right? So let's go to the converse. I'm going to say A, B, C. Let's say you have your DE here again. So what does the midpoint theorem converse says? So now this side is equal to this side, and you are told that this is parallel to that. So what can you learn from this? So this is now the midpoint theorem converse, which is that is the other direction. So that's like if your AD is equal to your DB, right? Which is this side is equal to this side, and your DE is parallel to BC. So and your BC, then your AE will be equal to your EC, and your DE is half that of BC. So here's the difference between the two. On the first one, you're given a triangle, right? And you're given a line DE that divides both of the sides equal, which is it joins the midpoints of the two sides of the triangle. And you are told that the joining line will be parallel to the third side, and it will be half the length of the third side. That's what you're given, and that's what you are told. On the second case, you are only told that. So the red part is what you're told, is what you are claiming is your claim. So the black thing is what you are told. So in this case, here you are told that you have a triangle ABC, and your DE joins the two sides, which is your AB and your AC. So what they are saying is that your AD, if your AD is equal to your BC, and your DE is parallel to BC, then your AE will be equal to your EC. So these are different. So there you're told that the two lines are parallel, and this will be half of that. Here you're told that this side will be equal to that side as well, if this is equal to this and these two are parallel. So this side is equal to this, and this is equal to half of that. So I'll just highlight like this. So that's what they're telling you. So what we have here, if you look what we have that this is equal to this, and this is parallel to this. So this side should be equal to that side, right? And this should be half of this. It's the converse. It's this one over here. It is the converse. Look, your PO is equal to OW, which means in this case, your AD is equal to your DB, fine. And your OR is parallel to WS, which we proved. In this case, which is your DE is parallel to your BC, which is that. So what you know is that now, this side should be equal to this side. So what does that mean? It means this side, these two sides, which is this side is equal to that side, no problem. And also your DE is equal to half BC. So which means your OR in this case is equal to half WS. So what we're going to say, okay, PR is equal to RS, and which is this last part, this from here, and our OR over there is equal to half of what? Of WS. Why? This is the midpoint theorem converse, right? In that case, we can work with this. So we say OR is equal to half of WS, then divide by WS, divide by WS. Get that your OR over WS is equal to 1 over 2, which implies that the ratio of OR to WS is equal to 1:2, which is what we're trying to prove to begin with. So the midpoint theorem converse is the one that helps us to solve this equation. So we're done with 10.2.1. I'm going to clean this part and then we'll do 10.2.2. Okay, so now we're doing 10.2.2. That's saying calculate the length of PT if ST is equal to 15 units. So they want us to find what? They want us to find PT, which is this entire length from here to there. So they want us to find this entire length here. And they have told us that ST is equal to 15 units. Right? ST is equal to 15 units. Fine. So, what you need to understand is that, so they want us to find PT. So we've already discovered from the midpoint theorem that this length is equal to this length over here. So now they want us to find this entire length over here. Fine. So what is it that we know? So we know that this in triangle TRO and triangle TSV, this side here is parallel to this one. You can see it's part of this line over here. And therefore, we can apply the proportionality theorem, which is this length over this length is equal to this length over that length over there. So what you can say, in triangle, TSV, and triangle TRO. Triangle TSV and TRO. What we can say is that your TV, right? Your TV over your TV, right? Over your VO should be the same as your TS over your SR. This is the proportionality theorem. What we should just prove in the first question. Why are we applying it? It's because our OR is parallel to WS, which in turn, if your OR is parallel to WS, which means your OR is also parallel to VS, because they both, your VS is part of your WS. So in that case, what is your TV over VO? Your TV is 3A over VO, which is 1A, is equal to TS, which you are given, is 15 over SR. So this and that go away, right? So you are left with 15 over SR is equal to 3 over 1. You cross multiply. If you cross multiply here, you get 3 SR is equal to 15. Divided by 3, divided by 3. Get that the SR is equal to 5 units. SR is equal to 5. Which means we know that this part here is what? Is 5 here. But this is equal to this, so which is this one is 5 as well. Right? Which means 5, your ST going to be 5 plus 5 plus 15. So which will come out maybe to be 25. So your ST, which is, or your PT, which is what they want. PT is equal to 5 plus 5 plus 15, which is equal to. So this is how I would have looked at this question. And I'm done here. And I hope this question does make sense to you, as it does to me. And I'm done with this question. Thank you for watching. Cheers.